So, all the stuff that we're doing, all we're doing, Jonah, is proportions. Proportion, right? What's proportional? It means they have the same ratio. What's the ratio? Like when we compare two things. So what we're going to do for the first one is we have side similarity. So it's saying if the corresponding sides of two triangles are proportional, the triangles are similar. So here we go. We already did this. We did this way back in the first, do you remember where we compared sides? So FG compares the same as AB, right? The two in red. GH corresponds to BC. And HF, the green one, corresponds to CA. If all three have the same ratio, then the triangles are similar. Similar means they're the same shape, but do they have to be the same size? No. Okay. Determine whether the triangles are similar by side similarity. Okay, so let's do that first part. Well, let's see first. We would need to compare. So 8 over 4 is going to be a ratio of? Right, so I'm comparing. Wait, hold on. Okay, 8 is the smallest side in this triangle, the one on the left. So we want to compare it to the smallest side here. We're going to reduce it, but remember, we want to keep it as a ratio. So it's going to be 2, but we want to make it 2 over 1. What would 10 have to correspond to? 5. Is 10 over 5 also 2 over 1? Yeah, so far we're good. But we have to check all three sides. So 12 and 6. Yeah. Okay, so if they are similar, so our answer here is yes. Write a similarity statement. Okay, so we did this yesterday also. PQR STU. Okay, then there's one more additional piece. Oh, you know what? I just realized I did this backwards. That's okay. Let's make this triangle A to triangle B. What did we get for the scale factor? 2 over 1. Sorry, I like to do A to B. I don't know why they did B to A. Maybe they just want to make it the smaller one.
Oh, so A
yeah. Yeah, I like to do it left to right, but I guess they just... Good? We did scale factor. Scale factor is just the ratio. We did that before. Okay. All right. Which triangles are similar to triangle ABC? Cool. Which one? How do we, okay, let's start with, let's check. The smallest side in triangle ABC is 6. So 6 compared to 4 would be 3 over 2. Let's just check these two first, okay? All right, we can compare 12 to 8. So 12 is the biggest side in this one. So we want to compare it to the biggest side in this one. So 12 over 8. Well, this one's flipped upside down, but yeah.
I know what I'm just saying.
I just compared like the biggest to the biggest. Is this also 3 over 2? Yeah. All right, so far we have the same ratio. Let's check 9 and 6. Is it 3 over 2 also? Yeah. Okay, so these two are similar. What about the last one? So, let's take 6. Right away, I know 6 over 6 is 1. No, so which two triangles are similar? ABC is similar to? Okay, where? Wait, if we start with A, this...
F. No.
Okay, hold on.
EGF.
Do you see how where the red and the blue meet? That's.
Wouldn't it be?
We have to start with D.
Yeah.
What?
D, E, F.
Yes.
This is the alphabet.
They're not always going to go in alphabetical order, but okay. Our last theorem. This is side angle side. Now remember, angles are congruent. So we have to have one angle congruent, but the lengths of the sides must be proportional. Okay? So we have to have like these two angles congruent, and then this and this have to have the same ratio, and this one and this one have to have the same ratio. Okay. Okay, let's determine whether the triangles are similar. Now, for this one, we don't have to do a scale factor. We're just, so first of all, do we have one pair of angles congruent? Yeah, so these two angles are the same. And then we want to check 8 over 6. What's that reduced to? 4 over 3? And then, well, we can only divide the top and the bottom by, that's okay. And then 12 and 8. We can divide the top and the bottom by 3 over 2. Uh-oh. Are they similar? No. So, just right now. You don't have to go any further. So, we had a congruent angle, but the pairs of sides did not match up, right? They didn't come out to be the same ratio. Let's check the next one. Okay, this one we did one similar to this yesterday also. Do you see how we have a little triangle? Yeah. Okay, so they both share angle P. So I'm going to compare 3 to what's the entire side of the big triangle? 6, which reduces to 1/2. And then do the same thing here. 5 over this whole side. So this one's yes. And then what would our similarity statement?
Yes.
We want to do PQR, the little one. Well, hold on. If we start with P, we have to start with P again. So PST, or did you say that? Sorry.
That's like the hardest one. Like the hardest part. Like, to do
The order?
Yeah.
If it's inside, just think it goes like the same direction. Like, right? If it's inside one inside the
And why
other.
does it have to start with P?
It has to be similar because they share the same P angles.
Right, but remember, just
have
because
to-
they share an angle doesn't mean they're the same.
Why does it have to start with P?
Because that's the angle that they have congruent.
No, but it's saying the P is the same. The P is congruent to the P.
Right, it's congruent to itself.
So we didn't have to do.
We didn't really have to do anything for that. We just had to check the two sides.
Okay.
Here, they don't have the, they're not the same like spot,
Yeah.
but here it's 84 and 84, so that's good. Now what do we want to check? 8 and 6. What's 8 over 6? We just did this. No. 4 over 3. And then we want to check 10 and 8.
10 over 8.
Divide by 2. 5 over 4. So this one's going to be no. Good. Okay, they share this side. So we're looking at this little triangle compared to the big triangle. 4 over 12. 4 over 12 is 1/3. Yeah, because you're comparing. So kind of think it's like the big triangle. There's a triangle within the triangle. So 4 compares to the whole side, which is 12. How about on the other side? 5 over 15. Good. So this one's going to be yes. Triangle. Okay, remember when I said it's VWX. and v, yz. Good. All right, up with that one.
Are these just the proportions?
These are going to be proportions. Now, there's a reason we were practicing FOIL yesterday. No, don't. It's going to be fine. Okay, there's only 2 examples on here. Okay, we're going to cross multiply. So we're going to take 8 plus, or x plus 8 times x minus 1, and we're going to multiply, we're going to make that equal to x times x plus 6. Okay, now this time, so Fred, you were just mentioning, it feels like we were leaving it unfinished. But now we're foiling and solving. So we're going to get an x, we're going to get an actual answer. Yes. Okay, so now we're going to FOIL. We get x squared, minus 1x plus 8x. Right. Remember what we were just practicing yesterday with the FOIL. Right? Minus x plus 8x minus 8. Okay, on the right side, I just have to distribute. So that's going to be x squared plus 6x. Okay, just going to go up here. So I have x squared plus 7x minus 6. Thank you, plus 6x. There we go. Sorry, I'm just moving over here. So I just combine like terms. I will pause.
Wait.
So the 7x comes from negative x and 8x.
Yeah,
right?
combining these, a negative 1x and a plus 8x. And then what?
The 6x. Where do you get the? I mean, the 6 is from where? Should it be negative 8? I got it. The 6 is from
No,
where?
there's x.
Wait,
plus
what did
6.
I do? Did I?
Oh yeah. Wait, no.
Oh,
No, it should be 9.
it should be a minus 8 here.
Oh, I was like, not
Sorry.
confused.
Wait, let's fix it.
That was supposed to be a minus 8. Sorry.
Okay.
Oh, no, no.
Okay,
There, I fixed it. Okay.
Wait, is this correct?
Okay.
Is this correct?
Yeah. Okay. What now? I could subtract
Subtract.
x squared from both sides. And what happens when I subtract x squared? It just goes away. So I have 7x minus 8.
And then minus 7 on both sides.
Okay. I purposely did this. I don't need you to worry about doing any factoring just yet. That we'll review on a different time. Remember working backwards, FOIL, factoring? Yeah, what would you do from here? You want to subtract 7x?
No, just subtract 6.
Oh, okay. No. Both are correct, guys. Both are correct. Divide by negative 1. So x equals 8. Okay. It's all right. It's all right. We should all get the same answer. Okay, let's try one more of these. X minus 4 and then times x plus 3. And we want to make this equal to x times x plus 2. You want to try it first? Sure.
Yeah, we do on our own.
Wow. You must feel so bad for it. Not really.
Did we get it yet? Is this one? Is it? Negative 4?
Can we work outside?
Where?
Like in the hallway or either like the. It's actually like really nice out.
Wait, sorry, I have a question. I'm forgetting. Do you multiply with
I'm just going to subtract x squared. Okay, so I get a negative x minus 12.
multiply with the second x to the other stuff or just the 3?
Just the, what do you mean? Oh, that's a plus x.
You know how it's like metaphors